Like, don't you have like 3 times like you can make the video?
All right, thank you for that. Let's start. The pH scale measures how acidic or how basic a substance is based on the amount or the concentration of hydrogen ions versus hydroxide ions in the solution. So let's go ahead and fill this in. How acidic or basic a substance is based on the amount or the concentration of hydrogen ions versus hydroxide ions. And so sometimes you'll see hydrogen as just H+, but I'm going to write it as H3O+. That's a hydronium ion, just to remind you that it's going to be used interchangeably with just an H+ ion versus hydroxide ions or the OH- ions in solution. And then as a reminder, just in case we didn't put this up here, I think in one of my other videos we actually went over it and did our pH scale up here, but in case we skipped it, it's going to match the same thing as down here. So if you wanted to go back and fill that in your own notes, this is the same thing. So the scale ranges from 0 to what? 14. 7 is going to be our midpoint, and anything with a pH of 7, what do we consider that? Acid, base, or neutral. So pH of 7 is neutral. Sorry, I asked that in a confusing way because there's below 7. If it's below 7, what is that? Perfect. And then above 7 would be
Base.
Y'all did your homework. Okay. So the pH scale is logarithmic, so that's why I wrote that word up on the board. L-O-G-A R-I-T-H-M-I-C. Every time I write it, I feel like it looks kind of weird. So the pH scale is logarithmic, meaning that it increases tenfold every time you change the number. As a result, each whole pH value below 7 is 10 times more acidic or 10 times more hydrogen ions than the next higher value. So, for example, a pH of 4 is going to be 10 times more acidic than a pH of 5. And if you go from 4 to 6, you're adding another 10 times. So it's going to be 10 times 10 times. So 100 times more acidic than a pH of 6. So pH of 4 is 100 times, which is 10 by 10, more acidic than a pH of 6. The same holds true for pH values above 7, each of which is 10 times more basic or contains 10 times more hydroxide ions than the one that came before it. So I don't want you all to get confused on this. With 7 being neutral, and this side is going to be acids, and this side is bases. As you get further away from neutral, so for acids having a low number or for bases having a high number, that is increasing the strength of something. And then something else I want to point out is that when we talk about acid and base strength, so this is what we talked about right before, this is the acid and base strength video. When we defined strong acids and strong bases versus weak acids and weak bases, that was defined by how much they dissociate, to the extent to which it was defined by the extent to which they dissociate. Meaning if they completely dissociate, that makes them strong, and if they don't completely dissociate, that makes them weak. So it is different than talking about the concentration. Here we're actually talking about the concentration in terms of like how dilute or concentrated something is. And then finally, in these brackets, the concentration of a solution measures the number of hydrogen ions or hydroxide ions. Remember that this could also be H3O plus hydronium in a solution, and it will always be given to you in brackets, and it'll contain an exponent. So it'll be something in scientific notation. So your strongest acids, meaning the ones that dissociate the most, will be down here, and your strongest bases will be over here. and a neutral solution is about a pH of 7. And then underneath this, we wrote that a change of 1 pH unit represents a 10-fold change in ion concentration. So a pH of 3 is going to be 10 times more acidic than a pH of 4 and 100 times more acidic than a pH of 5.
Sorry.
It's okay.
That was embarrassing.
Yes.
So when we calculate this, it says calculating pH using the hydrogen ion concentration, or you'll sometimes see it written as hydronium ion, so I'll put that there just to remind you again. They really are going to be used interchangeably. And hydroxide ion concentration. So the pH of a solution is the negative log of the hydrogen ion concentration. So if we put this into an equation, you need to know this equation and how to use it. It's going to be negative log of the hydrogen ion concentration, where this represents the molar concentration of hydrogen ions. So if we were to calculate this, so letter I, the H plus ion concentration is this number right here. If I wanted to calculate what the pH is, we're going to use our calculators. So let me pause real quick and I'll set up my calculator to show you how we'll plug this in. With that formula sitting in front of us, if we are going to calculate the pH using the formula of negative log of the hydrogen ion concentration, we're going to start by plugging into our calculator the negative button, which on this calculator is right here. So that thing that's like the negative in parentheses, you'll plug that in. Then you'll type log, which is that button right there. So negative log. Open your parentheses, and then we'll type in that 1.0 times 10 to the negative second value that was given to you for example 1. So I'm going to type in 1.0, and then to do anything in scientific notation, remember we do shift log, just like how we would do Avogadro's number when we did shift log to do times 10 to the 23rd power. And then we're going to do negative 2 as my exponent. So 1.0 times 10 to the negative second, close my parentheses, and when I hit enter, I got just 2 as my answer. So if my hydrogen ion concentration, if I'm looking at, oops, let's see if that goes back. Hide this guy. My hydrogen ion concentration is this. Then when I plug it into my calculator, my actual pH is just 2.
What'd you get?
2.
Like when you put it in that calculator, you got 2?
Yes. If you have a different calculator, so the other calculator that's in here, let me show you on that one. So if we're using the TI-84s, when you type this in, you would start with typing the negative button, so that's this button down here, so negative, and then I would type log, which is this button. So negative log. This one opens your parentheses for you, so you don't have to do that. So negative log, and then I would type in 1.0. So on my screen I see that. Then this one I would press second, and then the comma button is how you put the E on the screen for your times 10 to the power of something. And then your exponent is negative 2. So you type negative 2. Then you have to close your parentheses. And then this one would give you 2. So if you are struggling with that, go ahead and go back in the video to make sure that you understand which buttons to press on whichever calculator you are using. These are the 2 that are mostly available in my classroom. We also have this one. The only difference on this one would be how you do the exponent. So I'll just show you that one anyway. So negative button is down here again. Negative, the log button is up here. So negative log, and this one opens the parentheses again. I would do 1.0, and then second, EE again, and then a negative 2. And then close your parentheses, enter. So all 3 calculators, you get the same answer. Those are the different buttons that you'll press depending on what you have. If you have a calculator whose buttons don't match any of those 3, then I can help you when I get back, or maybe you can ask Ms. Harkreader to help you, but that is all we're typing in. Okay, so if I go back to this, 1.0 times, or the negative log of 1.0 times 10 to the negative 2 gave me a pH of 2. And when I have the pH, that helps me to easily identify, is this an acid, is it a base, or is it neutral? It's an acid. So let's circle that. And then this says, what is the number of hydrogen ions in decimal format? So if I were to take this number of ions of hydrogen and write that into decimal format, remember that that negative 2 tells me that I'm going to move the decimal in this number. I'm going to move that 2 places to the left, whatever direction makes it smaller. So I'm going to go 1, 2, and the decimal would go here, and I'd fill in the blank with a 0. Don't forget to use your leading 0. So this would be 0.01. And then we'll just carry our same unit. That M stands for molar. It tells us that right there. So the little trick in this is that if we're going from this to the decimal format, you're going to have 1 less 0 after the decimal than you do for your exponent. So in this one, if we were to convert this into decimal notation, you would have 6 zeros after the decimal. So we can just go ahead and write that. So 0.1, 2, 3, 4, 5, 6, and then a 1. So I can double check that by saying, okay, if I move this decimal, does it move 7 places to end up looking like that? And the answer is 1, 2, 3, 4, 5, 6, 7. So that's correct. So in this one, if I wanted to figure out what the pH is, if this is my hydrogen ion concentration.
Wouldn't the decimal go 1 stage further? What? Because it's 10.
Yeah, the 10 is what's telling you how many, like that's what's telling you to move the decimal at all. So like this is the tens place, or 10th place, and the 100th place, and the 1000th.
Decimal behind the 0, so you move it from the 0, and you know.
No, the decimal here is exactly where it's shown. It's like the decimal is right there. So you move it from wherever it's starting. This is the same rules for scientific notation that we learned at the beginning. Yeah. So like if I had something, so sometimes you'll see something that's technically not in scientific notation, but I guess just as a scientific notation reminder, we always do just 1 digit before the decimal, and then it's going to be times 10 to the power of something. This number, if it's positive, tells you you're going to move the decimal from here, whatever direction makes it bigger, so generally to the right. If it's a negative number, it tells you you'll move the decimal in the opposite direction to make it smaller. Yes?
Okay, back to the top, is 10 to the power negative 2 0.1, not 0.01?
What?
10 to the power negative 2 is not 0.1. Because you move it over twice. Then you multiply that by 1 to get the same thing. 0.1 minus 0.
So if I move my decimal is here.
Oh, 10 to the power 2 negative 2. You're multiplying it by 10 to the power negative 2.
Right.
And 1 is just 1. 10 to the power negative 2, you move it from 10 to 1 to 0.1.
So what is 10 to the power of negative 2?
0.1.
Is it?
Yeah.
It is. And 0.1 times 1 is what? 0.1, right?
10 to the power of negative 2. Now you got me all confused. 10 to the power of negative 2 is 0.01.
Oh yeah, it is.
Why are y'all trying to make me feel like I'm crazy for doing math? What? Okay, if you're not sure, plug it into your calculator. Plug in just 10 to the power of negative 2. It is not 0.1. You'll have me questioning everything I know about numbers. What? It is 0.01.
I was like, what?
I'm like, have I been teaching this wrong forever? No. 10 to the power of negative 2 is 0.01. And then we're multiplying that 0.01 times 1, so you just get 0.01. Does that clear up any confusion, or did that make it worse?
I have no idea what you just said.
Let's see if I can get a calculator to show up on...
Wait, half and half.
Okay, I realized something. 10 to the power 1 is 10. 10 to the power 0 is 1. And 10 to the power negative 1 is 0.1. So
Alright.
because keep missing 0.
When in doubt, use your calculator. I love scientific notation because the exponents don't lie. You move the decimal that many places. So to me, it always makes sense. It's really easy without a calculator. But if you're questioning your own sanity, use the calculator. Let's move on from that one. That was unnecessarily confusing. Number 2, Roman numeral 2 here, says 1.0 times 10 to the negative 7th. So I would move my decimal 7 places, and since it's negative, I'm going to move it 7 places to make the number smaller, which is what tells me I move it to the left. So that's why I did 1, 2, 3, 4, 5, 6, 7. Put that there, fill in all these other zeros, and you get 6 zeros. So that's why I got that over there. But then to figure out the pH of this one, I'm going to do the same thing that I did before, where I plug it into my calculator and I'm using this equation. I'm going to continue using the Casio calculators since that's the one that I think most students in here are going to be using, because that's what we have the most of. So if I type this in, it's going to start with the negative number, the negative sign, which is this, negative, and then I type log, open parentheses, and that number was 1.0 times 10 to the negative 7th, so I can either type it as a decimal with all those 6 zeros, or I can just type 1.0 and then shift log negative 7, and then close my parentheses. And I get 7. I'll get this same thing if I just did the negative log of 0.1234561. It will also give me 7. So if you calculated it correctly, if you plugged in the right number of zeros and all of that, then you would get the same number. So my pH in that example will be 7. And if I have a pH of 7, am I an acid, a base, or neutral? Neutral. And then this H plus ion concentration is 1.0 times 10 to the negative 9th. So go ahead and plug that one into your calculator as well. What'd you get? 9. Okay, so without even did you actually plug that into your calculator, or did you just notice it? If you actually plug it in, you'll get 9. And if you don't plug it in, what pattern are you noticing?
It's just not the negative.
Okay, perfect. So in all of these cases, you're multiplying it by 1, so you're taking the log, which means you're just bringing that exponent down to the front, and you're getting rid of the negative because that's part of our formula up there. Good. Make sense?
Yep.
Okay. And then if you have a pH of 9, are you an acid, a base, or neutral? Excellent. Okay, let's move down to the bottom of this page, where it says calculate the hydrogen ion concentration for the following solutions. So if you have a pH of 14, your pH can be calculated by taking the negative log of your hydrogen ion concentration, or a way that we can rearrange this equation that I don't know, I was kind of leaning towards not giving it to you, but at the same time, I feel like it's not that big of a deal. So probably, if Ms. Harkuter is okay with it, we'll end up giving this to you on your test, is that a way to rearrange this exact same equation is that your hydrogen ion concentration is going to equal your base of 10 to the negative pH.
So it's just 10
Because when we're doing log, we're doing automatically do log base of
basically
10.
just like plugging in.
Yes, exactly. And then just as far as formatting for each of these, if there is nothing in front of it, then we're going to show it for purposes of like significant figures and everything. I want you to show it times 1 point something something so that we have the correct number of significant figures. So what I mean by that is in this first example, if the pH is 14, if I actually wanted to plug this into my calculator and do the hydrogen ion concentration of 10 to the power of negative pH, I would show you the video again. On the calculator, plug in. You can just type in shift log, and that puts 10 to the power of something. And then my negative pH, if my pH is 14, I would type in negative 14. So 10 to the power of negative 14 equals 1 times 10 to the power of negative 14. Do you see that? So if you go through and you actually plug this into your calculator, it basically just puts that pH value as your exponent. I want you to get used to plugging this into your calculators because your calculations are going to get more complicated where you can't actually just do them in your head. But this one would be 1 times 10 to the 14th, but if I keep the correct sig figs, this one has how many? 3. So it would be 1.00 times 10 to the negative 14th power.
So.
Don't overthink it. If your pH is 14, are you an acid, a base, or neutral? What about a pH of 11? So if I were to follow this same format, you can plug it into your calculator and you can see, oops, I don't know if that ever showed. Just to make sure that showed up on there. Forgot about the video. All right, if you're doing pH of 11, you can plug that in as well. So your pH of 11 would be shift log to get 10 on the screen times or 10 to the negative 11th power, and you get 1 times 10 to the negative 11th. So if I get rid of this, do 1.0. The reason I know it's going to be 1.0 is because this has 2 significant figures, so I'm going to multiply that by 10 to the negative 11th power.
Oh, no, something. That's interesting.
If you are an academic chemistry student watching this video and you don't know what significant figures means, don't worry. We don't do sig figs in regular, so you just need to be able to put it as 1 times 10 to the something. All right, if you have a pH of 11, what is your status? Acid, base, or neutral? And then can you do the next one without using a calculator?
Yeah, sure.
What pattern did we notice?
The same thing we noticed from the last 3 questions.
Okay, so it's going to be 1.0. And is this acid, base, or neutral? Neutral. Perfect. All right, I do have calculation questions for you to do as practice where you're not just multiplying by 1 every time, which makes it a little bit more complicated, but your equations that you're going to use in all of those will be either this one or this one. So make sure that you keep these in mind and have them written in your notes for yourself.